Hi, everybody, and happy afternoon. Thank you so much for taking the time here to join us for this presentation. Gonna shoot for running about 40 minutes or so, digging into the topic of getting your machine to maybe run a little bit longer than just one little cycle, and reduce some of this setup time that you really can't put in your quote, but it takes time to set up those machines, right? So again, I really appreciate you guys taking the time to join this webinar. If you do have any questions, definitely make sure that you put them in the question area. We will definitely have time for that in the end. Let's jump into these couple of slides I have here. So just a quick intro. This is going to be the only bulletin you're going to see in this presentation. So a quick intro of who I am, and then I just read somewhere that by asking good questions you get good answers. So some of the things that we want to kind of try to cover here is how can we make more chips and have the machine sitting still less time, and also kind of being maybe a little bit more efficient inside of our cutting tool path. So I think I've invented a new phrase. We don't want to do too many MO6ing, if that's a word or a phrase. And then in the end, I want to share what I call Paul Mann's tool probe. So this was a little device that I kind of used back when I used to work in a manufacturing facility in Rochester. And I've shared it with a few people who are using it today. So I thought I would share that with you guys today here too. So who am I? Well, my name is Lars Christensen, as Matt said, and I work for Autodesk. Probably the two only interesting things I think about me is, one, I'm from Denmark, so that's why you have a little bit of an accent, but I've been living in the Buffalo, New York area for about 17 years now. And then I am a mold maker of trade, and have worked since the late 80s in different machine shops, both in Denmark and also in the United States, where I reside now. Maybe the most valuable thing I can share with you is my email address, lars.christensen@autodesk.com. This kind of falls pretty well with a webinar that I did here on Modern Machine Shop about a month ago. There was 5 tips to run unattended, and I'm sure there's a few people who maybe caught that webinar, maybe some didn't. You're definitely more than welcome to send me an email. I'll make sure you get a link for that one, that webinar. And then also, you can also put that in the comment area, by the way, because I get all the questions in the comment area too, and I'll make sure you get the link for this webinar. You will also find me out on some of the social networks. So I have a YouTube page where I talk quite a bit about CAD and CAM, and I have a Facebook page where I do some tips and tricks, so forth. So definitely love to connect with you on LinkedIn and all that stuff. But maybe my email is maybe the most valuable thing here, and then use the comment area. So last month at the 5 tips on how to run unattended, I kind of dated myself with this image because when I started in the industry, actually the first shop I worked at, we didn't have a CNC mill. It was all cranking handles, and I was joking that this Bridgeport here type Bridgeport machine is actually pretty advanced because it has a digital readout, and you actually there's a motor on the x-axis, so you only have to hand crank the Y and the Z. But what I have seen over the years is that really not have much, for many people, have changed from this image to where we are today with these bigger CNC machines. And what I'm talking about here is, if you look at the picture on the left, we have a nice curve riser on the table. And if you look at the picture on the right, well, it's kind of the same thing. We have a curve riser. And this was one of the things that I ran into in the early 2000s I was working at a manufacturing place in Rochester, New York, and it was a tool and die shop, and we were kind of converting from tool and die over to do more production run. But what was happening was that the tool makers were really approaching their CNC machines the same way that you approach a Bridgeport. What means that if the machine is needed, or the tool maker needed a mill, he would go over to the CNC mill. If he needed a lathe, he would go over to the lathe, and not really treating the machines much different than we did in the old days. So what we talked about in the Unattended webinar was how we could pile more stuff on the table and actually utilizing, the technology we have today. And that's kind of like what we are going to build on. But before I get to that though, so in the last webinar, I also shared my email address like I just did with you here. And I got a few questions because I made a comment to this Metsura 300 that I use to program. So this is an 11 pallet pool machine, and I think it fits pretty well with what we're going to talk about today. So one of the comments I made about this machine, so this was a great machine, and I loved running this machine. One of the comments I made was that it still only had one spindle though. So it has 11 pallets on it. It has about 200 tools, but still one spindle. So one of the questions I got was if I could, they wanted to know a little bit more what I meant by that comment. And, I think it fits kind of to what we're talking about today about running, having your mill run longer and reduce your setups. Well, on what I experienced on this 11 pallet pool machine is that, you have 11 pallets, so you put tombstones on it. This is a 4-axis machine. That means you end up with 44 sides on it. Well, if you could fit 8 parts on each side, then you end up with like 352 parts. Now, if you have a cycle time per part about 9 minutes, sounds pretty reasonable if you can fit 8 parts on one side. Well, then you're running 53 hours to get through all 11 pallets because, again, you only still have one spindle. So that was kind of like my point that, that's all great, but now you need a person, to load up, keeping the machine fat. You also need to find a job that can let you do that. What is probably a bigger task than actually finding an operator to load the machine. So I guess my point was just that, go big or go home is great, but one of the complications with a machine like this is that, you still only have one spindle, and you have to have the right work for that. And that goes for everything that, of course, we're showing about today. Now, what I'm going to be using today of software is 3 software packages that we offer at Autodesk. I will say, though, that if I do a decent job, and you be the judge of that, definitely I would love your comments. Send me an email or put them in the comment area if you don't agree with me. But if I do a decent job today, it doesn't really matter what type of CAM software you're using. If you're using Gibbs CAM or Mastercam or some of the other ones, they do have similar type of functions at what I am going to be using today. Also, I normally in the end get asked about pricing. I have a power slide with that, but I don't want to get into pricing right now. I really want to get into today's topic here. So let's jump into to software here and get going. So what you see on the screen here was where I left off in last month's webinar, talking about running unattended. I'm really trying to fit a little bit more on your machining table than just one curve vise and be done with it. Because what happens is that when you only have one vise, you only, can many times only machine one part at a time, and that means that setup becomes like this huge overhead, right? And like I said right when I started, when you're quoting machining, it's really hard to charge for setup time. Most people don't want to charge for you to set up the machine, but you know, before you look around, you spend 45 minutes easily setting up on the mill. So some of the things you can do is kind of like trying to add more things to the milling table, and you maybe you're running all of the things at the same time, or maybe you're just picking out what you have in there. So what we had from the overnight run is these two type of vices. One is a orange vise with a dual station in it, and the other one is a curved vise with a little fixture in it on this sub plate. And what I was talking about was what's nice about mounting this on a sub plate here is that you can now, at the beginning of the day, you can take, you know, everything out of the machine and maybe load the overnight run outside the machine while you now have the table freed up for running during the day. Then at the end of the day, you can put this sub plate back in with all the vices on it, a new pounce loaded, and hit go and run. I also talked a little bit about, you know, if you have the right type of job, something like a axis over here gives you an option to kind of machine multiple sides of parts. Now, of course, all this kind of like depends on what type of parts you can bring into your shop, right? But I was a big fan of batching things together, and when we started running overnight, we actually did it like only on Tuesdays and Thursdays. So we kind of like batched the work together that fit in within the overnight envelope. Now, so what I did for today's topic, where we're going to talk about making your mill, you know, running longer between setting up, was I wanted to introduce another type of vise. So what I'm doing is I'm swapping out this orange vise that is a dual setup with another type of vise that is definitely very handy. And these vices here are specifically from a company called Tombstone City. I use these, had great luck with them, but I know that other manufacturers are making similar ones. I know Kurt has something similar to it. What is special about these type of vices is that each jaw are actually sitting on teeth. I hope that kind of like shows up in the image here. So what that means is that this type of vise, you can actually move things around. So now you can actually take these different solid jaws that I'm highlighting here, and you can actually shift them around for different types of parts. So this gives you the flexibility to actually run, you know, get a little bit of bigger variety of different type of parts. Now I'm going to come back to this setup in a little bit when I jump into Inventor. Right now we're inside of Fusion 360. But one of the things I wanted to show about these vices, why I wanted to show about these vices, is I actually sometimes took like this whole end section here and I replaced it to something like this. And this maybe shows up a little bit better if I've already programmed something, turn my stock on here. Now I'm almost using the bottom half of these vices as a standard vice, where I still have room for some other parts over here. So I guess what I'm kind of talking about here is, you know, if you can set up your machine so it is a little bit more flexible for different type of parts, that gives you an option to run different styles and not constantly have to, you know, fit things within one vise, take the vise out, clamping things to the table, and so forth, so you are sitting still all the time. So definitely think about your work holding, and I'm not affiliated with any of these. This is what I have used in industry and found extremely helpful. So in this case here, kind of like machining a part that I normally would run in a standard Kurt vise style, but now it's actually running on the bottom end of this Tombstone vise, where you can adjust and you can now program other parts. Now, if you didn't see the webinar from last month, let me just move over to the Kurt vise here and just quickly just talk a little bit about what we have over here. So I use these parts, or a variation of these parts, in my last webinar. And what we have here is actually a fixture within the Kurt vise. So I used to do this quite a bit, makes it really handy. So not only just holding your part in the Kurt vise, but actually start building fixtures that you can hold within there. And then of course you can have a pickup hole or something on this fixture so you can take it in and out. Now just to take a look at this fixture here, let me just quickly hide the parts here. This fixture could just be machined out of, for example, 6061 aluminum or something. And what I'm using here is something called Mighty Bite clamps. Use those quite a bit. And these are actually machinable, so you can machine that radius on whatever your part is. But you will actually see I'm using them over on the A-axis also, another variation of these Mighty Bite clamps. These are called Uniforce over here. So think about actually being able to, create some of your fixturing inside of your machine and either make it so you can take it in and out by, putting a pickup hole in or something like that, or literally, machine a fixture as it's sitting in the vise, so you know that the relationship between these holes and when you put the parts into them are going to be perfect. Because that's what would happen if I put this raw block of 6061 in here and I machined out the fixture and then I plugged the parts in. Well, then we can agree on that I would have, pretty accurate parts, right? I wouldn't have, it's only when you start taking things in and out the devices that you run into issues. Now, of course, again, this all depends on what type of parts you are machining. But this can really, if you start setting parts up around on your table, playing around with that, that really gives you a big advantage. And being inside of something like what I'm using today, what is Fusion 360, Inventor, or SolidWorks, really gives you an opportunity to design right inside of the environment in here where I'm also going to be programming. So this is where I'm going to put my CAM Toolpath on. And what I see here is an exact picture of what is out of the machine. What makes it a lot easier to program, what means that I don't have to spend a lot of time out of the machine verifying things, because I know that what I have in my CAD system is what I have out of the machine. So that's just some of the things to consider when you're in this environment here too. One of the things I actually showed in the last webinar, I'm not going to do that here, is that as part changes, if you get a change from your customer, you can actually also have your fixturing update with it. So again, if you're interested in seeing how that works, put a comment in there that you would like the link for the last webinar, or send me an email. Now, one of the things I showed in my last webinar was how quickly we can program parts by only programming one and then reusing that data on multiple parts. So here we have 8 parts that is in kind of like the same size, right? The same batch. And one of the questions that came up from that was, how can you optimizing your tool path so your cutter is more engaged with the material than it is making tool changes and so on. So I just thought I would show that here, and we can kind of like just dig into that and make sure that we get that straightened out here. So let me just jump into my CAM environment here, and I already have a setup for this part. So let's just go in and throw a couple of toolpath on it. So what I'm going to do is I am going to rough the part out. I'm going to use what is called a 2D adaptive clearing. I'm not going to get too much in depth with all the menus and stuff like that within this, because like I said, it doesn't really matter if you're using GibbsCAM, Mastercam, or something else. Most of these type of toolpaths is there. Now I will note I'm going to rough it out with the same end mill that you saw. I just did that part over to the right over there. So I'm going to hit OK. And I'm just going to select right on that model here. So we have our rough toolpath. Well, let's just go ahead and simulate that. Hit play. And I'm not going to tweak things, but you can kind of like see we quickly kind of like get that roughed out there. I am also going to do a finishing operation. So I'm going to go ahead and select what is called a contour on that same thing. Now I'm going to select a 3/16 end mill for that. And I'm going to select the same edge just to finish around there. So we got that. And then you will see there's a little hole up on the top. And I'm going to just go in and do a what is called a circular toolpath on that with the same tool. It's not really too important. So what I have now is free toolpath, and that is going to finish off that part. So it's going to rough it. It's going to finish the outside, and then it's just going to do the center hole there. Now, what I showed in the last webinar was how easily I can apply these toolpaths to the rest of these parts. So all I'm going to do is I'm just going to go in and highlight them, and I'm going to right click and go in and say I'm going to create a pattern from these. And you get different options in here. You can either do like a linear pattern where you choose how far you want the jump to go. You can see a little jump pop-up shows it there. You can do circular patterns, but the one I picked was called a component pattern. What that means is that when I select my part that I programmed, it will find all the same parts that is in here. So just like that, I have now programmed all of them. Now, one of the questions that came out of the last webinar was there is order of operations. So I just wanted to take a second to show that, you know, this is extremely important when you're trying to, you know, become better at programming. Like I used to, you know, when I used to train machinists, I used to tell them that, you know, you want to become like the pit crew at Formula One or at NASCAR, where it's just absolutely, you know, you're top notch, the best out there. And knowing some of these functions is very important. If you already know these, by the way, if you're feeling completely comfortable with what I'm going to show you now, well, I think you should pat yourself on the back, because then you are actually, you know, in the top 10% of people who understand utilizing technology. So the first one called preserve order. And it's pretty straightforward what happens. When I click that, it's going to do it's going to do things in the order that it was programmed. So it's going to rough and it's going to finish. It's going to move on to the next one. It's going to rough and it's going to finish. And, you know, this looks great. But one of the issues, of course, here is that we see multiple tool changes, right? It's going to change to a big color. It's going to go for each part. So from an efficiency standpoint, you will get the job done. But from an efficiency standpoint, this is not great. So the next option, if we go in here and edit, is called order by operation. Now, what that really just means is we have programmed those we have these three operations, so it's just going to go through each of them individually. What does look a little better, because what we're going to see is that our big end mill is going to finish each one up of what is good, but what you will see happens when we get to our smaller end mill, and let's see if I can, here comes the smaller end mill, you will see it's not doing the whole up on top because it's finishing each operation as it's going, what means that we have the right amount of tool changes, but we're actually taking a tour, one extra winning tour around the part here. So the last option is order by tool. So now we will see that it is going to do each part by the tool. So now the first one's going to do just like it did before. It's going to run through here. I'm trying to speed it up, but I can't. There we go. And but now you will see that it's finishing at the top. So this is the way that you very quickly can program in your CAM software like this. but also where these small settings that is within whatever CAM system you're using can mean that you can be more efficient in how you're programming. I think it's worth thinking about this, right, and utilizing these tools in here. Now, another thing I just quickly also wanted to show that I think is important. When I programmed, I actually did this in SolidWorks or with HSMWorks in the last webinar. This one here, I'm going to do it in Fusion. I programmed this part here, and I have a setup for it here. So I'm just going to go in and make that active. And let me just apply a adaptive clearing here. I'm going to use that same end mill that we now machined this part down in the lower left, our little fixture here, and then I'm going to use the same one over here to rough this part in. And all I'm going to make sure is I only wanted to machine to this depth here. All right, like that. Now I'm using adaptive clearing here for this, it's a really great toolpath. What you will see though, when I go in and simulate this, let me turn the stock on here and hit play. You will see down at the bottom, I actually have some red lines down at the bottom of my screen because I'm going to have some collisions because that my tool is not sticking far enough out of the holder, and it will actually collide with the stock. It actually shows, first of all, you see the tool turns red, but you would actually also see that it get a big gash right here. This is not pretty, of course, and you know, I made a phrase in the last webinar, no sparks in the dark, and that is definitely still the case. You know, anybody who ever had a tool holder hit either a fixture or stock knows what I'm talking about. But what I showed was that there was a couple of different options in here that can help us with this. If you go down to the bottom, there's something called shaft holder detection, and that exists both within Fusion 360, within Inventor HSM, and also within HSMWorks that runs inside SolidWorks. What I can do in here, I have some different options. One is called pull away, where the tool will actually stay away, so it knows where the tool and the holder is, will actually step away from the part. What means that it's going to leave more material down here because that's where it would collide. So the tool actually backs away from the stock. But of course it's helpful because we're not colliding with our part. It will leave some more material for our finishing operations, of course. But the other one I showed was the one that is called Detect Tool Length. And when you select Detect Tool Length, the software will actually go in and analyze, and you will see the tool is going to be further out of the holder. Just like that. You see how it just extended the tool out of the holder to be able to come down here without crashing. It actually gives us a little warning over here, and if I right click and go in and hit show log, it will actually show us that the tool length has been extended 30 millimeters. Now the reason that I'm showing you this is because I think it's important that you know that this takes effect all across. What means that the first part of program down here, if we go into that one, that toolpath actually needs to be regenerated also because that it have taken effect all the way through that tool is now longer, not just on that part we just did it on, but the software is actually smart enough to know that it needs to do that on all three places that we are using this. So what this means is by having using these kind of options that is inside of your CAM software, it lets you do less testing out at your machine and therefore saving you time. So your machine can run, and run longer. I hope this is super helpful. So just to end out with Fusion here, so think about how you can add more fixturing and parts on your machine but also how you can utilize some of the things within your CAM system to help you to program while the machine is running. So when you have that downtime where you got to load programs in and change parts and so forth, that you can trust that what you're putting in there is good. That takes us to the next thing I want to talk about, and that is posts and probing. So let me just jump over to Inventor here. So this is the setup I showed you as the second one, where I have these different parts still sitting inside of these Tombstone City vices. Like I said, it could also be other types. These are just nice because they have these flexibility to move all the jaws. But one of the things that I showed in the last webinar was probing. And I'm going to show you my cheap man's probe. If you don't have either a Spindle probe, or if you have a Spindle probe, or if you don't have a Spindle probe, you might have a table probe here. You can utilize that with the poor man's probe, but you don't even have to. But first, let me talk about the standard Spindle probe that maybe is in your machine and how you can utilize that. So what I want to concentrate on here is we got these 3 parts sitting here, and I already got one set up for one part, so you can kind of like see how that highlights right here. Now, one of the things that I used to run into was even if you're running small batches of what I call production, so let's say you got to run 8 parts of something and you loaded them into your vices, you will always have some kind of a stop in there, but still misloads can happen. One of the things that is really neat, I think is one of the biggest things that have happened in milling recently, is the Spindle probes and how you can utilize them to actually set your work offset, not just when you're setting up your buys or picking up your part in the beginning, but you can actually use them throughout your program. So let me show you what I'm talking about here. So right now I'm inside of Inventor, but if I go in here and I say I want to do a probing cycle, I'm just going to go in and select my probe in here, and I'm going to select what do I want to probe, and I'm going to select the top face here. So what I'm getting now is I'm getting a probing cycle that's going to go in and find the center of this part. I can just quickly simulate it so you can see what I'm talking about. I'll hit play here. So you see the probe's going to go in and it's going to pick up the center of this part here. What is really neat about this is I can actually use the probe to kind of reset my work offset. So if I set my work offset up to one being G54, G55, G56, I can actually have it so you can put these parts in here, but even if you don't get them right up to the stop, if you just get them close, I can actually have my program re-pick up the part and reset up that G54. So let me show you what I mean by that. So for this operation, I'm going to set a facing operation. I'm going to do this quick. Again, I'm going to use our 1/2" machine here. So like that. I have a facing operation, and I'm also just going to quickly do a 2.5 axis. Now I'm going to change my tool to a little bit of smaller, to a 1/4" end mill, and I'm going to just pick the bottom here. Again, my point is not so much about programming a part. I'm just making a couple of operations. So what I have here is I have a cycle for machining where my machine is going to go in and begin by picking up the part, resetting the G54, then it's going to face off the part, and then it's going to rough out that center pocket. Now what I can do is I can create a setup for the next part down here. So really what I'm doing now is that I am not relying on 100% on people putting the part 100% correctly in the machine. I can actually have an operator load the parts in and assure that if there is an issue, if one part is just, let's say, 20 thousandths or something off the mark, that my software will actually be corrected. And I'll do that right in here. So G57 or G56 is actually number 2 right here. So I'm setting that here. So that means now this is G56, no, sorry, G55, right? This is G54, number 2 is G55. So this will be G55. And all I'm going to do is go up and just copy these 3 operations. So right click, hit copy, and paste those to my next operation right here. Like that. And then all I have to do is just going in and just tell it that it is actually this face that I want to probe now. And the facing operation, I don't have to do anything with. The roughing for the pocket, I have to do the same thing. I just have to go in and tell it that it is the bottom of in here, just like that. And now I have just made this one here. It's going to pick up the part. It's going to reset G54. It's going to machine this part. It's going to then go down to this part. It's going to repick this one up so that that is G55 and machine that part. And then we can just go down and do one more for the last one. So now you are making sure that you're not relying on human error when they're loading these parts in, because if they load it completely off, then the probe will actually throw an alarm because it would either hit a surface that it shouldn't hit anyways. So this is kind of like a way that you can utilize what I call technology if you have Tool Probe. I'm going to show you in a second if you don't. So this one here is going to be number 3. What is 56? Yes. So 54, 55, 56. There we go. And again, I'm just going to paste this in here. And let me just reset. My probing surface is now here. Okay. The facing operation we don't have to do anything with, because it's smart enough to know. And then the roughing operation, I'm just going to re-pick up this surface right here. Okay, so we now have set up a way where we can have the machine helping us less downtime because we can load the parts in quicker. And if I actually go and I post this out, because let's just face it, all this is just tools. The code is what matters. So let me go out here and just post this out. And it's giving me a warning that I'm using multiple work setups, so my posts have to be set up for that. But of course, with our software, we have all these posts are shipping with the software, and we also have another post dedicated page. I'm not worried about that. Let me just post this out as a Haas post. And you will see here we got our code. So what we get is we get the probe cycle. So this is a Renishaw type probe, just using macros. And it will go in and will pick up the G54 again and reset that. So our first facing operation is now the G54. And now after that, it's going to do the roughing operation. If I just go down to my next tool change, you will then see the next one, it does the G55 on the second part, resetting that, and then it's using G55 for that facing operation. And of course, the last one does the G56. So be aware of these kinds of function that makes you be out of the machine quicker to get things going. Now, and I think that this was pretty quick programmed. I mean, like multiple stage setups. You could, of course, also do that with some kind of subroutine. All right, I'm going to wrap this up here. The last thing I wanted to show was what I call the poor man probe. So let me just jump over to SolidWorks here. I could have done that inside of Inventor too, but I just thought, why not show you that in here. So I have kind of like the same setup as you just saw. The biggest difference here, though, is that I have the blank stock in here, right, before it has been machined. What I did that was extremely helpful was I had, well, this actually started on a robo drill with a pallet chainsaw where I had no either tool, table preset, or spindle probe. But what I did was I created this little graphite probe. And if I go in and edit the sketch, it might be a little bit easier just to see here, I think, hopefully. So all this is a graphic rod that is about a quarter inch in diameter and 4 inches long. And you can buy those for like, you know, a couple of cents. And what I did was I got them ground by one of the guys in our tool room, and this is extremely easy. Graphite is, you know, it's like a pencil, so it's extremely easy to grind. And what I did was I made it sure that it was pretty precise diameter of 1/8 of an inch, and then I made it, you know, a quarter inch long. And then this area up here was kind of like the breaking point for this. So what I did with this little graphite probe was, well, I actually brought it into my CAM software as a customized tool. So let me show you how you can do that. So what I did was I created a couple of sketch lines, what is just standard sketching that you can do in whatever CAD and CAM system you have, and you can drive those sketch lines. So I just made a sketch line that was like 25 thousandths past or outside my stock part. So when I go in here and create a tool path here, I go into my tool library, you can actually create custom tools. So I'm going to do that. So I'm going to say I'm going to create a new mill, and I can create that form mill, and now I can actually pull in that SolidWorks part file you just saw. So I call that a cheap man's probe. Oops, I must have passed it. I can do the alphabet right there. Cheap probe. So there you will see the probe. Now I can adjust how long I want it out of my tool holder. You know, you can adjust all this. And I actually going to do it to the minor diameter right there. So here I have this graphite holder sitting in a standard tool holder. And what I would do with that was, before I started machining anything, I would literally drive down these two sketch lines like this, and I just need to give it a depth. So what I want, like, is a 25 thousandths or so clearance. So if the operator misplaced a part, this little 20-cent graphite probe would break, and then you could just regrind on it, of course. So let me just hit play here. You can see it run. So here you can see the holder comes down. Whoops. See, that one would actually hit. Let's just go in and reverse the direction on that. So that second one's going to go that way. There we go. So what you will see here is that the probe will come spinning down along the side, and this could be a like high feed rate, right? Almost rapid move. And if that little end is still intact afterwards, well, then you know that you're good. But if it is not, then you know that there's a misload part, which is definitely a lot better than than breaking tools. Let's go in here on the end here and take a little bit closer look at it. And if you have a table probe, you could go ahead and check that at the end. Let me just hit play so you can see it here. So it's going to come down, and then you can see how it's just very close to the edge. The top here, the gray area here is your stock, and that will make sure that, you know, if there is any parts that is not loaded correctly, that little tip there would break off. If you do have a table probe, then you can actually go in. I go back into the tool library where we were before. Right in here, let's go ahead and edit the tool. I could actually turn on brake control right here. So now if I had a table probe, every time this tool I've run, it would go down and make sure that that little tip is there or broken out. Now on this robo drill that I did it on, didn't have anything on that, so it just required that, you know, it will run before any tools ran, and then it would have an M00 stop, and then it would, you know, the operator would have to stick his head inside the machine and just confirm that that little tip was there. And if the little tip was there, well, then you were good to go. Again, avoiding you spending a lot of time on kind of like trying to troubleshoot a lot. So let me just get back into the PowerPoint here and do the recap before we go to the questions. So first of all, post-processors. Definitely make sure your post-processors are tweaked. I showed you what we have inside of our software. We also have another library. I can show you that if anybody put that in the comment area. Play around with the layout on your machine to make sure not only you can put more parts on the table, but also think of ways you can be more flexible. So like in this case here where you have a sub plate you can take in and out. So now all devices are indicated in. So if you're just throwing everything in on this plate, all you have to do is maybe indicate that straight and pick one hole up, and everything is where you want it. Makes it helpful if you have it drawn up in your CAD system. Work with your work offsets too. Make sure you're comfortable with how you can use your work offsets. Most machines actually have passed the G59. So most people are familiar with G54. You got 55, 56, 59, 57, 8, 9. But then you actually also have more. So make sure you know those so you can utilize those. There's a G54.1, 0.2, and so forth. And, you know, these spindle probes, I honestly think are a great investment. Definitely something to consider, especially when we're talking about reducing your setup time, instead of have to play around with edge finders and indicators. And then, of course, you know, no sparks in the dark. This poor man's probe here is definitely also another thing you can utilize. And again, I handed out my email, and I'll make sure I'll get to the email here. My email is right here, lars.christensen@autodesk.com. You're definitely more than welcome to shoot me an email too, and we can take this offline if you really want to do that.